Hello! In today's episode of Organic Chemistry Made Easy, we are going to talk about the Wolff-Kishner reduction. It was discovered by Nikolai Kishner and Ludwig Wolff in 1921. This process reduces the carbonyl group in a structure to a methylene group. Let's take a look at the basics. So the goal of the Wolff-Kishner is to reduce the CO carbonyl group to CH2. What we're going to have to start is either an aldehyde or a ketone, hydrazine, and a base. We will have an intermediate in this process, which is called the hydrazone, which we will see here. And eventually, that is reduced to an alkane. So how does this reaction work exactly? Let's take a look at the full mechanism. To start with, the first step is actually a series of processes to create the hydrazone. We start with addition, when hydrazine attacks the carbonyl, which breaks the original double bond. Now, if you look at our structure, we have a nitrogen atom with 4 bonds, and therefore a positive charge, giving the structure some acidity. If you remember, we have basic condition thanks to our OH base, which will then take one of the hydrogens off of the acidic nitrogen to create a water molecule. Next, we will see an additional proton exchange with the formed water, the H2O molecule, and our lone oxygen to create a hydroxyl group as well as hydroxide again. It will then attack the NH bond like so. This will allow us to have our intermediate of the hydrazone. We will use the generated hydroxide from the previous elimination step to deprotonate at the terminal nitrogen, causing a nitrogen-nitrogen double bond and a carbanion. Protonation will now take place at the site of the carbon atom to complete the tautomerization process using the water molecule we had formed in the previous step. Perhaps you can begin to see a pattern now, as once again we have hydroxide left over that we will use to then take another proton away from the terminal nitrogen. As you can see, this will then eliminate our nitrogen gas, which is actually an irreversible step. The loss of the stable nitrogen gas will create an extremely basic carbanion. With one final proton exchange of the highly basic carbanion, we will get our final reduced product. And that is how the Wolff-Kishner reduction works. It is a simple idea to comprehend, but the mechanism is quite elegant and detailed. Thank you for joining us in another episode of Organic Chemistry Made Easy. See you guys tomorrow.